Okay guys, so this is part 3 of this long video. We already showed you guys how to find the y-intercept, which was 0, -8. We already discussed how to find the x-intercept, which we found 2 of them in different multiplicities. Today, we're going to talk about finding the end behavior. And what is end behavior once again? It's basically, if I had a graph, end behavior is what's happening at the end of the graphs. When I check an x that's way to the right, I can tell that my y is up. I can tell that my y is up. This is basically what's end behavior. What's happening at the end? Well, let me give you an example. When my x approaches a big positive number, so going to the right, I need to know where is my function going. Where is my function going? Same thing for when my x is approaching a negative number. In other words, going to the left. I need to know where my function is going. Well, let's answer these questions, guys. For the first one, when my x is a big positive number, let's plug it in. So we have 3 parentheses. Let's pick a big positive number, positive infinity. You can think of it as positive million, whatever you want, but just a big positive number. And then same thing over here, guys. It's going to be a big positive number. Plus 2 squared. Don't forget it's squared. Let's go ahead and solve, guys. Well, 3 times a big positive number, like a million. Well, that will make it still big positive, right? Minus 2. Over here, guys, a big positive plus 2, still positive. Don't forget you're squaring. But guys, if I had 3 million minus 2, let's say, isn't that still positive? Well, yep, that's going to stay positive. Well, positive a million to the power of 2, that would still stay positive. So when you multiply them, I'm still going to get a positive answer. I don't care about the number right now. I just want to know if it's positive or negative. So when you put a big positive number, my y is going to be big positive. In other words, my y is going up, right? Now let's do the same thing, but let's check with the negative. So I'm going to erase this real quick. I'm going to check with negatives now. What happens if you change that positive into a negative like this? Okay, well, what's a 3 times a negative big number? That's going to be a negative still, right? There we go. Well, what's a negative big number plus 2? It's like saying negative a million plus 2. The negative is still going to win. But don't forget, you are squaring it. What happens? Let's go over here, guys. Negative infinity minus 2, that's going to remain negative. But guys, what's a negative infinity to the power of 2? That's like saying negative times negative, which gives me a positive answer. Well, who wins when you multiply? The negative or the positive? The negative is always going to win. So when my x is a negative big number, my function is going to go negative, which means it's going down. So we already guessed it, guys. If I were to graph this, let me do a new graph here. If I had a graph, I know that my x and y, when my x is a big positive, so when my x is going this way, my y is going up. So my graph is going to end over here, somewhere on top. And when my x is negative, when I'm going this way, and my y is going to be going down, so my graph is going to start somewhere on that side. That's the end behavior of the graph. We still don't know how the graph looks in the middle. We just know how the graph looks at the end. Check out my part 4 to find out how this graph is going to look.